Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello and welcome to the Health Upgrade Podcast. Today we're going to go over the basics of vagus nerve and vagus nerve stimulation and the impact and the interaction it has with the immune system. We're going to do this in a kind of a mini episode today as a quick overview of how everything kind of works. So let's jump right in. When most people think about the autonomic nervous system, they imagine the network of nerves that control things that happen in our bodies that we have no conscious control of, like heart rate, digestion, and kidney function. When pressed, most people probably recognize that the autonomic nervous system also controls things that we can exert some conscious control over, like breathing, blinking, and swallowing. The story about how the effects of the autonomic nervous system has on things that prior to the last couple of decades, most people wouldn't ever think the nervous system could have any influence on at all, including inflammation, mood, cognitive ability, and metabolism. Let's dig into this.
Sure. The discovery of the autonomic nervous system's control over these really, frankly, remarkable aspects of life has come about at the same time that another set of discoveries were also happening involving the immune system, and they're sort of converging. It turns out that the innate immune system, which is part of our immune system, that's the part that we think about when we're dealing with injuries and pathogens that we haven't seen before and we haven't built up antibodies to, that's actually the architect, builder, and maintenance crew for every organ and tissue from the skin and bones to heart and brain in our bodies. It has only recently become clear that both sets of discoveries, the ones about the autonomic nervous system and the ones about the innate immune system, are converging, as I said, into really, frankly, one of the greatest stories in medicine of the past century.
Yeah, and I'm going to say very clearly that's how the autonomic nervous system and the innate immune system partnered together to form this fundamental control system for our overall health that exists in all of our knowledge at this point. So let's figure out how this works. It is true that for humans, as well as nearly every other complex animal on the planet, that this interaction between the autonomic nervous system and the innate immune system is necessary. So let's dig into that.
Yeah, let's start again with the autonomic nervous system. It's got two arms. There's the sympathetic and the parasympathetic. Talked about this on other podcasts, but we're doing this mini episode to sort of bring everybody up to speed. The sympathetic activity or the sympathetic nervous system is the one that leads to our fight, flight, and freeze modes, in which stress is extremely high and the immune system responds to it with inflammatory signaling designed to protect us against harm. So when you get inflamed or you get stressed, they're really two sides of the same sympathetic activation coin.
It is important to note that low levels or brief periods of these intense sympathetic activities is actually required for our survival. This is our fight or flight response to stressors or challenges that were worrisome for our survival overall. So vigorous exercise or an intense project at work or just even swerving to avoid an accident on the road are all examples of situations in which sympathetic activity is both helpful and necessary.
Exactly. Activation of the parasympathetic arm, which is the opposite of that, it's primarily the vagus nerve. So when we talk about activation of the parasympathetic, we can also say activation of the vagus, shifts us back into the opposite mode, opposite of fight, flight, and freeze, which is rest, digest, relax, and restore. That mode is where immune cells and your nervous system shift out of that inflammatory state or that stress state and return to doing their most important jobs, which they should be doing most of the time. And those jobs are what keep us healthy.
Yeah, and this last part might actually require a little explaining because you just mentioned that immune cells have to stop being inflammatory and revert back to a different state in order to keep us healthy. That may sound backwards to those who only think of the immune system as being valuable when it comes to fighting against foreign invaders or responding to injury, or even fighting against mutated cells within our body.
Well, I assure you, I didn't misspeak, so I'll explain. The innate immune system is the more basic form of immunity, in as much as it doesn't learn to recognize specific features of a new virus or bacteria in the way that the adaptive immune cells do, with antibodies and T cells roaming around the body waiting for the next encounter with chickenpox or last season's flu or the measles. which we all got vaccinated for. We can think of the adaptive immune cells as the sort of career officers and specialists in the military. They're the ones who learn their lessons in the classroom and simulators before ever going into battle. But the innate immune system is more like the enlisted men on the front lines. Sure, they get some training, but they're sort of thrust out into the battle without the same level of specialization. So they need some basic instruction if they're going to go into those kind of battles. Generally, these are the soldiers who only spend a short time in the military, and after serving, they go back to their families or go to college or take the trade that they learned in the military and, build a career, build families, work hard, and they never pick up a weapon again. They never go into battle again. I know that's a long-winded analogy, but I used it because one of the cell types that's most commonly associated with the innate immune system is the macrophage. And despite what the textbooks of the last 2 decades taught, and frankly, the history of the last 140 years since the discovery of macrophages, is that what we're learning now is that these cells are certainly not career warriors, even though they're so important when we go to war against pathogens or viruses and bacteria and other things. That's not what their primary job is. These cells are, as I said before, the architects, builders, and maintenance teams that literally construct our organs, our vasculature, the nervous system, digestive tract, even our skin and bones. They don't just build them during gestation. They remain in these organs and tissues for our entire lives, maintaining them, keeping them functioning through thick and thin. But these tissues are just like the family farm, if we go back to that analogy again, just like the family farm. If the farmer gets called away to go fight in a war, the farm sort of falls apart. Doesn't happen immediately, but if the battle lasts for too long, the crops will fail, the livestock will scatter, the buildings start to decay. The families that are relying on that farm to produce food, they suffer. And the worst possible outcome of a prolonged battle, we've all seen it in the real world, is that even when the farmer returns, the soldier comes out of the military, they've been changed so profoundly by the experiences of war that they're really unable to return to that same job and do it as effectively. And in the case of the farm never sort of regains its prior efficiency and productivity. This is what happens to macrophages when they haven't been allowed to revert back to their civilian form, if you will, for a really long time. And that's the way in which chronic inflammation leaves the macrophages basically in a state of PTSD. I mean, they basically have this, we'll call it PISD, post-inflammation, stress, dysfunction.
I think we just came up with a new word, PISD, a new acronym. I love it. So let's dig into what that means for a moment. And that is that the macrophages may not learn the way that adaptive immune cells do, i.e. literally transforming their genome into a specific killer for one part of a virus or other pathogen, but they do change as a result of prolonged inflammatory activity. One very important way that they change is through the production of energy. So these cells, like most of the cells in the body, use circulating glucose or sugar as a fuel source. And in the first step, these cells metabolize this glucose through a chemical process known as glycolysis. This produces about 4 units of energy, and these units are called ATP per glucose molecule. So 4 ATP per glucose molecule. We can think of these little ATP molecules or units of energy as little batteries that provide energy to the various machines being used all around the cell. The second step involves a cell organelle that most likely was at one time during evolution a separate life form that simply joined into other cells because they were such prodigious energy producers. It was a very synergistic coming together of these organelles or these two life forms. And these organelles are now known as mitochondria, and they take the refuse, basically the byproducts of the glucose or the glycolysis function, to produce more ATP. And they come out with about 30 more molecules of ATP per glucose molecule. So it's a very energy efficient process. They're actually great at helping to produce a lot more energy. They are absolutely incredible power plants. They're necessary for life as we know it. And just like the real power plants in our real world, they do produce some waste, and the processes that they carry out do come with some wear and tear. And this is what we know as oxidative stress. So during healthy and non-inflammatory times, these cells and the mitochondria themselves produce things like melatonin, which is actually a downstream product from serotonin, which in turn is produced from tryptophan. So there's a whole cascade here. Tryptophan is the amino acid, becomes over a multi-step process, serotonin, which then transforms into melatonin. And that melatonin is a remarkable scavenger of reactive oxygen species, helping to decrease DNA damage that's caused by this oxidative stress that comes from these waste byproducts. And this is helpful to actually manage and maintain those mitochondria. And yes, those mitochondria themselves even have their own DNA, which leads us to understand that these were likely two different life forms that actually came together. And when that damage unfortunately starts to build up, and this is when we're in a more inflammatory state, the mitochondria become more dysfunctional. And this is what leads to more inflammation within the cell and can actually lead to the cell eventually committing suicide through a process called apoptosis.
Exactly. And following this soldier analogy that I was using before, probably farther than I should, the vagus nerve, which is again that parasympathetic rest, digest, and restore side of the autonomic nervous system, serves as the therapist, if you will, to the soldiering macrophage, helping them transition out of that mindset of battle back into their civilian job. And it does this through the release of a neurotransmitter called acetylcholine, which is the primary neurotransmitter released by the vagus nerve. And without going into the complicated biochemical pathways that we've talked about before, the release of this acetylcholine binds to a class of receptors on the surface of these macrophages, and the same receptors also present on the mitochondrial power plants that we've just been talking about. And there are several ways and several pathways to accomplish all of these tasks, and they're all complementary to one another. So each one of these places in which this receptor resides and where acetylcholine might bind, they're all trying to do the same thing, which is to shut down inflammation, protect the cell, and protect and restore that mitochondrial function so that the mitochondria can continue to function. And just to give you a quick sense as to the sorts of tasks that these macrophages do when they're in that healthy and sort of civilian state and where they are, we can think about macrophages in the brain. They're called microglial cells. When they're functioning properly, they literally, as we said before, they build the organs. So these microglial cells are literally building the brain, growing and maintaining the blood vessels and support cells and helping neurons proliferate, grow, and migrate to the right locations, and then connecting them properly to function in the right ways. When microglia are inflamed, cognitive function, mood, pain levels, and other things worsen. It's just like that farmer who's left the farm for too long, the farm starts to break down. So the brain starts to break down and it ceases to be able to function as efficiently. And in fact, in some cases, if it's long enough, if that inflammation lasts long enough, the very structure of the brain can degenerate. We see that in degenerative disorders. But this can also happen early in life. And we've talked about on other podcasts about that during childhood, even in the womb, this can happen. And that can lead to neurodevelopmental problems like autism and schizophrenia or epilepsy and ADHD. And sometimes these early inflammatory challenges, which can be physical, they don't have to be just in the brain. They can be part of your body. They can be part of an emotional stress or mental stress, can lead to problems later in the years of your life in the form of fibromyalgia, chronic fatigue, migraine, cognitive dysfunction, depression, and anxiety. And that's why we see a lot of early childhood, either early childhood illness or early childhood abuse in patients who have, as adults, these what appear to be medical conditions, but they're medical in the sense of being immunological dysfunction that is residual or carried forward from that earlier priming that occurred early in life. And for most of us, a lifetime of challenges, it doesn't have to happen early in life and it doesn't have to be just abuse. It's the normal wear and tear that we do on ourselves just through life and living that can end up leading to a degeneration, which for some people can be quite extreme and can lead to noticeable to even, frankly, utterly incapacitating conditions like Parkinsonism and Alzheimer's.
It's important to note as well that this degeneration doesn't happen only in one particular organ, the brain. This happens in every single one of our organs, from our heart, our liver, our kidneys, our blood vessels, bones, and even skin. And it's important to keep the macrophages that are present in each of those organs doing their regular housekeeping tasks at an optimal level. And that's truly what longevity and increasing our health span is all about.
Yeah. If stress and challenges are inevitable, that doesn't mean that we can't do our best to avoid these problems from arising. And how we do that, the answers really truly appear to come to include, every effort to enhance our parasympathetic activity. You want that vagal tone to be high. So doing so, we do things like exercise. The goal is to optimize our immune health and get those acetylcholine levels, that release of acetylcholine from that parasympathetic nervous system to be increased. That will decrease the inflammation, and the inflammatory response is oftentimes higher than it needs to be. So we want to make certain that that's the most efficient and minimized inflammatory response, and facilitate our innate immune cells returning to those housekeeping tasks as easily and as fluidly as possible, and thereby maintaining our organs and regenerating our tissues when necessary so that we can thrive.
How can we ensure that we have that correct level of parasympathetic vagus nerve activation?
Well, first and foremost, we have to do our best to de-stress our lives. Carve out some relaxing place for us to go to recharge our batteries. It's not just recharging that ATP, it's recharging ourselves emotionally, mentally, get the right amount of sleep, eating whole foods and avoiding processed ones, sleeping a solid minimum 7.5 hours a night. And frankly, exercise, I said it before, I'm going to say it again, exercise is one of the greatest ways that you can maintain your body and it's not just maintaining it in keeping fat off or, keeping our muscles toned. It's about maintaining our immune system in that homeostatic state, non-inflamed. But if you want to take it to the next level, or if you're trying to make up for not being able to do the basics, like, we don't have enough time to exercise, we don't have enough time to sleep, there are activities, things like meditation, yoga, deep breathing techniques, even chanting and humming and gargling water that can activate that vagus nerve, that upregulate that parasympathetic activity. There are also medical devices and a few wellness products that are available, reasonably priced, handheld, non-invasive things that help us by using electricity to upregulate the tone, modulate the frequency of the vagus nerve, because again, the immune system responds to the right frequency in the vagus nerve. That's what we mean when we upregulate it. We're upregulating its frequency to the right levels. And these devices, which are new and available now, readily available, can be really potent tools for optimizing your health. And, finding the one that fits with your lifestyle is a great tool for upgrading your health.
I truly believe that we're blessed to have some of the most complicated machines in the history of the universe, and that is our body. And we're getting a glimpse into how our bodies work and into the instruction manual that we're trying to figure out how this whole system works well. And for me, this interaction between the autonomic nervous system and the immune system teaming up to keep us healthy and functioning well longer is essentially my hope for everyone's longer, better, healthier, happier life. So taking the time to understand exactly how stimulation of the vagus nerve can do that and can empower you to make better decisions and show up as your best self for you, for your loved ones, for your friends on an everyday basis, for me is an absolute must. And so that's how I think we can help to upgrade our overall health, is by understanding that this interaction is so necessary to be maintained. And there are ways that we can improve the health of our vagus nerve and our immune system just by working them together.
Agreed. That's the idea of the health upgrade. We want to upgrade our health.
Exactly. And I don't think we could have said it any better. So wonderful episode here, a very brief but easy overview of how vagus nerve affects the immune system, how the interaction is kind of put together, the basic biomechanical function within there, and biochemical function within there. But I think this will help to give people a very basic but simple understanding of how important this system truly is, this interaction truly is, and help you take some positive steps in your journey to upgrade your health. Have a wonderful day. Thank you so much for joining me, JP. And we'll have to hear you or have you join us on the next one. Enjoy.
Looking forward to it. Thank you.